What is up, Flutter devs? Today we're going to implement the loop and noLoop calls in our continuing port of processing to Flutter. Let's go have a look. Here is noLoop. Why are we implementing noLoop? Well, we have this ongoing problem with our tests that now that we animate, when the golden files or when the golden toolkit says pump and settle, it waits for the animations to stop. The animations never stop. The test fails. I don't have a silver bullet solution to that testing problem. However, in processing, there is this call, which is called noLoop, which stops the animation loop. If we implement noLoop, and if we call that from every test, then I think our test will go back to passing. Now, this comes with the downside that we need to invoke this in every test. But what I'm currently doing requires adjustments in every test. And what I'm currently, in fact, let me show you what I'm currently doing, just in case you haven't watched those videos. Let me open up a test. Here's transform test. This custom pump right here is what I'm doing to get the test to run. This looks a whole lot scarier, in my opinion, than just calling noLoop. And in fact, it's based on this knowledge that we are operating at 60 frames per second. And who even knows if that's necessarily going to be true on a CI server? Who knows if some test might try to change the frame rate? And then, I mean, this is brittle, and it requires some kind of fine-grained knowledge of at least golden toolkit, if not how Flutter tests run to begin with. Instead of custom pump, what I would like to be able to do is right up here in the draw call, just say noLoop. And if we do that in every single test, then the problem theoretically should go away. Still not perfect. I'll still be on the lookout for a better solution, but we've got to do something to get these tests passing again and get ourselves out of a broken state. So let's see if we can implement this, and then let's see if it actually solves our problem. I don't know. We'll see. Let's come into core. At first, we might think, let's have a variable that keeps track of whether or not to loop. But that's not really going to solve our problem. Let's remember how we're looping in the first place. We have this processing stateful widget, which has a corresponding state object, which has this ticker. The ticker automatically begins when the widget appears. It restarts when the sketch is changed, and then it doesn't stop ticking until we dispose of it down here. That's what we need to change. We need to be able to start and stop this ticker. Just having a variable in our sketch object here isn't going to solve that problem. You can flip that variable all day. It's not doing anything to the ticker. Therefore, I think what we want here is essentially a delegate. We want our state object to give the sketch a reference to methods that the sketch should call when someone calls loop or noLoop on the sketch. And I will just demonstrate what that looks like in my head. Here in our state object, we can say void noLoop to do, void loop to do. Okay. Let's say that somehow somebody calls this noLoop inside of our state object, which they can't right now. You can't call that from a sketch. That's not going to work. But if someone could call this noLoop, what do we actually want to do? Well, we would want to say if ticker. Now, is active versus is ticking. I always get these confused. Let's go look at their definition. Whether this ticker has scheduled a call to call its callback on the next frame. A ticker that is muted can be active, yet not be ticking. In that case, the ticker will not call its callback. Given that we are not muting it, I think we can just ask whether or not it's ticking. I'm not entirely... If we deal with this concept of muting it, then it sounds like the elapsed time will continue to move forward even though we're not ticking. And that's not a world that we want to get into. We either want to be on or off. We don't want this middle ground. So I think we can just ask if it's ticking, then we can say ticker stop. And if it's already not ticking, then we don't need to stop it. Down here for loop, if not ticker is ticking, then ticker dot start. I think that's probably enough. Maybe we'll run into some issue with elapsed time. Let's see, elapsed time, how is that used to calculate the frame count? The question is, are we going to reset the elapsed time? And if we reset the elapsed time, are we going to mess with the frame count? We set the elapsed time here, and then we do, so the frame count will keep going, but the elapsed time is used to calculate the actual frame rate. I don't know. Let's wait till that becomes a problem, I guess. It won't be a problem in our tests, I don't think. It might be a problem in practice. If it becomes a problem in practice, then we'll change it and we'll write some tests specifically for that problem. But still, these two methods are just defined within our state object. They have no relationship to the sketch. What we want is we want our sketch to have two functions as delegates. Void callback, loop, and void callback noLoop. These are now inside of our sketch object. Back up here in our widget, when we init state, we are going to say widget.sketch.loop equals our private state method called loop, and then widget.sketch noLoop equals noLoop. We have now connected the sketch object given to our widget, and in fact we can cascade these. We've taken our sketch object and we've connected it to our state object. We've now set up a delegate relationship, but we also need to do that down here. If the sketch has changed, then, so first we need to say old widget dot sketch loop equals null and no loop equals null. And I think these need to be nullable. And those should be single equal sign. Okay, and then we need to take the new widget, and so we've switched out widgets in did update widget. The old sketch we need to disconnect from, the new sketch we connect ourselves to. Now, stopping and starting the ticker should actually only happen if the new sketch wants to loop. So it turns out we actually do need a variable to track this. Here in sketch again, we will say is looping, and we will initialize that to true because by default we loop. Back up here in our widget, if widget.sketch.isLooping, then we will restart the ticker. Actually, we want to stop the ticker no matter what, but we only want to start it if the sketch wants it to be started. All right, I think the plumbing is done now, but we still need to make it possible for people to invoke these methods on an actual sketch. And by the way, what group are these in? noLoop under structure. Okay, then we want a structure group for this. Let's put that under environment. Now let's put it above environment. I guess it's above environment in the docs. We'll put it above environment here. And I guess we will capture these variables in there as well. Start structure. And then we want loop and we want noLoop. So is looping here is false, and then noLoop, if it exists, we will call it. Here is looping is true, and if loop exists, we will call it. Let's save that, go back to the test. Notice that our test compiles, so noLoop exists. We don't know if it does what we want or not. But now I'm going to come down here, I'm going to comment out this custom pump. And then I'm going to say Flutter test plain name equals translate example 1. Let's see what happens. It says it passed. It says it passed. Let's delete that golden file and let's regenerate it. Okay, back to Goldens, and there it is. Although it seems to think it's a different file, even though it's got the same name and theoretically the same data. Oh well, yeah, looks the same. Now we have to apply this to all of our tests, and that's the downside of doing this. And I'm sure there probably is we could have some kind of global variable that we read inside of the processing widget. I'm not comfortable with that without thinking through it more. So this is using something that's built into processing to also fix our tests until I decide on a more universal solution. All right, so that's transform and then shape. I think we have probably a lot of tests in here to add this to. Okay. All right, now let's rerun that test file. Shape 2D. Let's see what happens. Sweet, they passed. And that's the biggest chunk so far. So I think there shouldn't be too many more tests for us to do this too. Here's another one that had the custom pump. Let's get rid of that. We'll put noLoop in setup, which I think is a fine place to do that. I think we'll still get one draw call, even though setup says noLoop. And here's another custom pump. Let's get rid of that. noLoop. Another custom pump. All right, that's environment, core. That's just making sure things compile. Well, it paints the default background color, I guess. And then setting. Okay, we got a few tests in here. Let's cascade these together because for some reason they weren't. Okay. All right, let's run all of them and see what fails. Okay, two tests failed. Let's see what happened here. Actually, you know what? Even that one that I said that's just painting the background, which I'm pretty sure is one of these. See, environment size, example 1. And then setup paints light gray background. Yeah. So even core, we still need to tell it in setup not to loop. Now with that, we should be down to one failing test. Okay, and it's a complaint about environment size, example 1, close others. Here we are in environment size, example 1. And the complaint is failures, master image, test image. Interesting. All right, what are we doing in here? Okay, I think what's happening here is that when we change the size, that we really do need Flutter to rebuild the widget tree. We don't need it to keep rebuilding forever, but we need it to rebuild at least once to apply the new size. I think we're going to have to handle that case specifically. We're going to have to know that when the size changes, we need to redraw. So let's again see how we're dealing with this. Up here in our widget, here we have the size, but we don't know when the size changes. I think we're going to have to repeat the same strategy that we had before, which is going to be like this: on size change, and then we're going to call set state. I think we have to set this as a delegate on the sketch object itself. In sketch, Let's see where size is. Desired width and height. Where's that defined? That's defined up here. We also need we need a void callback on size changed. On size changed. We change. I don't know what the right version of that name should be. In any event, this needs to be invoked when the size is changed. I'm going to make it changed. I think that's more appropriate. This is another delegate and it's private. So again, this is not public sketch behavior or processing behavior. This is private to us making this work in Flutter. Then we have to repeat also, we have to set that up here. So on size changed equals on, and I have a mixed naming of this, on size changed. Let's see, why is it complaining? Void callback, optional. Oh, we don't want to invoke it. We just want to assign it. Then when we lose a sketch, when it goes away, we need to set it to null. And when we get a new sketch, we need to set it back to what it was. And by the way, we are assuming here that we always have a sketch. That's not optional, right? Yeah, it's required. So we're always getting one. Still probably safer to check to make sure it's non-null, but we're not going to do that. Okay, let's see if this fixes that test, and we'll run the whole battery of tests to see if we've broken anything else along the way. Okay, same test failing, probably for the same reason. Okay, build scheduled during a frame. The problem here is that in onSized changed, we are calling setState, but we are in the middle of running a custom painter. In other words, we are in the process of creating a frame while we are requesting a new frame. The answer to that problem is to use the widgets binding to add a post frame callback. This allows the current frame to finish, and then as soon as the current frame is done, we immediately request a new frame. And then on the next frame, because unless you change the size again, this won't be called, and so there's no endless loop that you have to worry about. Let's again run the battery of tests. And we fail again. Well, that's a very small difference. Let's go see what it looks like now. Here's the master image. Here's the test image. Okay, we're now missing the drawing. Why is the drawing not taking place? So this is not being run. Or actually, that's not necessarily true. I think this is a problem once again with our frame rate behavior, which is just kind of a mess. I think we're running both of these on frame 1, and then I think we're rendering another frame, but because we're not passing an explicit time to the test system, our frame rate logic, this right here, I think is triggering. It's saying, well, not enough time has passed, so we're not going to draw another frame. I think I'm just going to comment this out, and I'm going to say figure out how to correctly support varying frame rates. We will keep the frame count and the calculation and everything, but essentially what this means by commenting this out, and we'll see if it actually fixes the test, but assuming it fixes the test, this means that you can request whatever frame rate you want, but for now, you're just going to get the natural platform frame rate. And let's see if it fixes the environment test, and let's see if it breaks other stuff. Okay, all tests now pass. So this frame rate stuff is something that I still need to figure out. But with that, we now have, at least we think we have loop and no loop. Maybe I'll write some more specialized tests for loop and no loop in the future, but I really just wanted it to get implemented to the point where we could fix all of our tests, and then hopefully it works. We'll see in the future. But that's it for today, and I'll catch you in the next video.